All right, we'll start with number 17. In the directions for number 17, it says we have to solve the equation, okay? So to solve these equations, we are going to use what we talked about before. It's called the zero product property, okay? And this is something we talked about last week. So this is, or sorry, last time. This is where you set it equal to 0. So if you look at number 17, is my equation set equal to 0? And the answer is yes, it's set equal to 0 here. So step 1 is done. Step 2, which is the most difficult step of all, is we want to turn our polynomial into a multiplication problem, which we call factored form. The way we do this is by factoring, okay? So you should be comfortable with some form of factoring, which is, I think, GCF for you guys. That's what you were talking about this week, is GCF. There's actually multiple forms of factoring, and we're starting with GCF, okay? So if we look at our problem 17, is it a multiplication problem? In other words, do I have 2 guys, 3 guys, 4 guys? Do I have multiple guys being multiplied together? And the answer is yes. We call this a factor because it's something that's multiplying to another factor. Okay, so in this case, we have 2 factors that are multiplying. And when that happens, we already know it's in factored form. So in essence, we did not have to do step 2. It was done for us. So all we have to go now and do is step 3. We're going to take each factor and put it equal to 0 and solve. Okay, so I'm going to take this factor, set it equal to 0. And then we're going to take the second factor and set that equal to 0. And because we have 2 factors, you should have 2 equations. And all we're going to do now is solve these equations like we did back in August. We're going to split the equations, and our goal is to get our variable by itself. So if you remember, we're going to add 2 first. That cancels. We're left with 3 times d equal to 2. And then we're going to divide by 3. Because it's multiplying, we divide. So my answer here is going to be d equals to 2/3. It's okay to get fractions. Not a big deal. Okay, so that's one answer. Let's go ahead and do the same thing for the second equation. Subtract 5. 2 times d. And then we're going to divide by 2. And that's going to give me d equal to -5/2. Again, another fraction, which is okay to have fractions as answers. So that's how we do these things. Like I mentioned before, the hardest part is going to be step 2, which you'll see. You're going to have to do step 2 in a couple problems. All right? So let's jump over to 19. Go through the steps again. Again, we are trying to solve here. And in order to solve these complex polynomials, we got to make sure, is it equal to 0? Yes, it is equal to 0. Step 2, do we have to factor it, or is it already in factored form? Do I have things just multiplying with each other? If you notice, we actually have things multiplying with each other. This is a factor. This is a factor. And the definition of factor is something that multiplies with something else. This is a factor. So these are all factors because they're multiplying with each other. So if you look, I have 4 factors and they're all multiplying. There's no plus or minus sign in between these parentheses, which means it's multiplication. So that tells me step 2 is already done. We didn't have to factor because it's already in factored form. So now step 3 says set each of these factors equal to 0. So we're going to have 4 equations here. So we have 4x equal to 0, x plus 5 equal to 0, 2x minus 1 equal to 0, and 4x plus 7 equal to 0. And guess what we got to do? We got to solve each one. Okay? So the first one, like we always do, we split it with the equation. And it's multiplying. 4 is multiplying, so the opposite of multiplication is division. 0 divided by 4 is actually 0. So we have one answer. X equals 0. Same thing here. We're going to get x by itself by subtracting 5 to both sides. X equals negative 5. 2 answers. To solve this one, we're going to first add 1 to both sides. So you have 2 times x equal to 1. And then divide 2 because it's multiplying. And x is going to equal to 1/2. 3 answers. And then last but not least, solve the last equation. So we're going to subtract 7. And we have 4 times x equal to negative 7. Divide by 4. And x is going to equal to negative 7 over 4. All right, and that's how we do those. Those were already factored form, so they were factored for us. Okay, let's jump to 21. In number 21, we're going to do the same process, but you'll notice the problem looks very different than these problems up here. Okay, these are in factored form. As you can see, this is not. We have addition and subtraction of stuff. Not everything's multiplying with each other. So this is called standard form. So we got to turn standard form into factored form. Okay, so let's go ahead and go through these steps. First of all, let's make sure it's equal to 0, which is good. Second, we got to turn it into factored form, and we're going to do factoring. Okay, so the only style of factoring you know right now, we'll get into more later, but right now the only style of factoring we know is GCF. So if you remember GCF from last time we met, we're looking for the biggest number and or variable that can divide every term. So as a reminder, we have 2 terms here. These are called terms. And what we're trying to find is, can I think of a number, looking at the number in the first term, 3, and a number in the second term, 12. Can I think of a number that divides both 3 and 12? And if you recall, last time we met, I said the best thing to do is make a list of numbers that divide the smaller number. So I'm going to make a list of numbers that divide 3. And those are 1 and 3. Okay? Then ask yourself, starting with the bigger number that you made a list with, so the bigger number in my list is 3, can 3 divide 12? And the answer is yes. So that means 3 is my greatest or biggest number that can divide both of them. You also can make a list for the second number if you'd like, just to see how this compares. So the list of numbers that divide 12 are 1, 2, 3, 6, and 12. And you'll notice the biggest number they have in common is 3. That's why it's my GCF. Okay? The next thing we want to do is look at the variables. If the terms have the same variable, same letter, then that's also part of my GCF. So they both have an X. So I'm going to put my X with my GCF. And then I have to just be careful what power I put here. So if you look, you always want to choose the smaller power. So this is power of 2. This is power of 1. So that means I have x to the power of 1, which we just write as x. Okay, Once we do that, we are going to divide our polynomial, our standard form polynomial, by our GCF. And this is stuff we did last time in Zoom. So if you're confused, check out last Zooms and it explains it. Check out the video on Monday and it will also explain it. So we're going to divide by our GCF and let's do the math. 3 divided by 3 is 1. Okay, so we'll put 1. We have x to the second. We're taking x away. So we have basically 2 x's and we want to take 1 away, which means we're left with 1. Negative 12 divided by 3 is negative 4. Careful with your sign there. We have 1 x on top and we're going to take 1 away. So that means there's no more x's. They cancel out. This answer goes in parentheses because remember, we want to turn it into a multiplication problem. So we have to put parentheses around this guy. And to turn a multiplication problem, we multiply by our GCF. Okay, this is in factored form, but remember, it's still equal to 0 because it's our equation. So we have just turned into factor form by factoring using GCF. Now we're going to set each factor equal to 0 and solve. So the first factor that we have is 3x. This is a factor. And this is my second factor because they are multiplying with each other. So that's factored form. So we're going to go 3x equal to 0 and 1x minus 4 or x minus 4 equal to 0. Set them equal to 0 and solve. So just like we did earlier. Divide by 3 to both sides. X is equal to 0. 0 divided by 3 is 0. Here we're going to add 4 to both sides. X is equal to 4. We have just solved by factoring. Okay? All right, we're going to skip this section. We're going to go to the next section, which is a little more difficult. Okay, so I'll let you complete those after I dismiss you. So I did 3 problems there for you. Hopefully that helps you out and explains everything that's going on. Let's jump over to the next section. All right, so we're going to do number 25. Same idea. Is it equal to 0? And the answer for number 25 is yes, it's equal to 0. We don't have to do anything there. Is it in factored form? And the answer is no, it's in standard form. So we're going to factor using GCF. So we have to find our GCF here. Okay, so again we have 15 and 6. This is the first term, this is the second term. So I like to start with the smaller number 6 and I'm going to list everything that divides 6. So that's 1, 2, 3, and 6. Okay, so then I'm going to check, can 6, starting with the bigger number in our list, can 6 divide 15? If you want, throw that in calculator. 15 divided by 6, and you'll notice it gives you a decimal. It doesn't work. Okay, can 3 divide 15 evenly? And the answer is yes. 3 can divide 15. We already know it could divide 6 because it was in our list. So 3 is the biggest number that can divide both of them. So our GCF is 3. Again, if you want to make the list for 15, you can. Your list would look like this. 1, 3, 5, 15, and you'll notice 3 and 3 are the common dividers, common factor. Okay, so we took care of the number GCF. Now we're going to take care of the variable. Do they share the same letter? Each term has the same letter G, so that means G has to be part of our GCF. And now we just pick the lower powered one. So we have a power of 2 here, a power of 1 here. So we're going to use G to the power of 1, which we write as just G. So this is my GCF. We're still in step 2. We got a factor, which means I got to divide this guy. This is all part of step 2 in these steps over here. Okay, we're still factoring by GCF. So let's go ahead and do this. 15 divided by 3, that's 5. We have one g on top. I'm taking a g away, so there's no more g's. They cancel out. Positive 6 divided by 3, that gives me positive 2. We have two g's on top. I'm taking one away. That gives me 1g. This goes in parentheses, and we turn it into a multiplication problem by multiplying by our GCF. So I'm going to put my GCF multiplying in front. Okay, when we write it like that, that really just means multiplication. It's still set equal to 0, and now we can go ahead and split up our first factor and put it equal to 0, and our second factor equal to 0. So our first factor is 3g. That is equal to 0. Remember, you got to set it equal to 0. That's step number 3 we're doing now. Set each factor equal to 0. Okay, and then we're going to set our other factor equal to 0. 5 plus 2g, or 2 times g equal to 0. And now we just got to solve. So we're going to divide by 3 here, and g is going to equal 0. Okay. Over here, we are going to get g by itself. So to get g by itself, we got to get rid of addition or subtraction first. Remember, the 2 is multiplying. So we have to get rid of the 5. What's the sign in front of the 5? It's adding. So we're going to subtract 5 to both sides. Always get rid of addition, subtraction first. So now we have 2 times g equals to negative 5. Now we get rid of multiplication by dividing by 2. And g equals negative 5 over 2. Okay? And hopefully you're starting to notice it's the same process over and over again. Okay? All right, let's go ahead and jump over to 27. Okay, if you look at number 27, we got to solve it exactly the same way. So what we have to do is we have to make sure it's equal to 0. If you notice, they're not equal to 0. So we have to either move the 8x squared to the right or the 20x to the left so it could be set equal to 0. And remember, anytime you're moving anything with the variable, all you got to do is add it or subtract it across the equal sign to move it. So in other words, if I want to move the 8x squared, since it's adding or positive 8x squared, I'm going to subtract 8x squared to both sides. If I want to move the positive 20x, I got to subtract 20x to both sides, okay? So here we have to figure out who do we want to move. And here's the rule I want you to remember. In order to set it equal to 0, you want to keep the highest power term, so x squared, you want to keep him positive. Okay? So in this case, the higher power is x squared. To keep him positive, he's already positive, so we do not want to move him. What we want to do is we want to move the other term, which is the lower power term, and we can move him because we don't care if he's negative. So in other words, we want to keep the highest power term positive if you have to set equal to 0. So for this particular example, that means I want to move the 20x. So I'm going to subtract 20x to both sides. Okay, this turns into 0 or cancels out, but we want it to be 0. On the left side, these are not like terms, so we can't write them or add them and subtract them together. We're just going to write them as a subtraction problem because this is negative. So your highest power usually wants to go first, and it has to be positive. So 8x squared, then it's negative 20x or minus 20x, all equal to, on the right side, turned into 0. Okay? Now these look like the problems we had before. Okay? So that's step 1. I set it equal to 0 by moving the lower power term. Okay? You want to move the lower power term, or you want to keep the higher power term positive. Make sure it stays positive. All right, now if you look, this is not factored form, so we got to do GCF again. So we're going to go a little faster here. Okay, so I'm not going to make my entire lists, but I'm just going to make a list of the smaller number in our term. So 8 is the smaller number in our term. So everything that divides 8 is listed here. 1, 2, 4, and 8. And then I'm going to check starting with the biggest number in our term because we want the greatest common factor. Can 8 divide 20? No. Can 4 divide 20? Yes. So 4 is my GCF. Okay, it can divide 20. Now we look at the variables. Do they share a variable? Yes, they share an x. What's the lowest power? It's a single x, x to the first, so that goes in my GCF. Now we divide by our GCF. This gives me 2x, okay? This is going to give me -5, all right? Remember here we had 2 x's, 1 x goes away, that's why we're left with 1 x. We had 1 x, I'm taking 1 x away, that's why we're left with no x. This goes in parentheses, and we put our GCF in front to make it a multiplication problem. It's in factor form, but it's still set equal to 0. Now we're going to split up each factor and set it equal to 0. Step 3. 4x equal to 0. 2x minus 5 equal to 0. Okay? So now solve. I'm going to divide both sides by 4 here because 4 is multiplying. To get rid of multiplication, you divide. This is going to give me x equal to 0. That's one answer. Over here, I'm going to add 5. And this gives me 2x equal to 5. And now I'm going to divide 5, or divide 2. And x equals 5 over 2. Okay? Cool. I'm going to do 29 real quick with very little explanation. Okay? But let's go through 29 and then we'll call it a day. I'll get you out of here and you can do the rest of the problems. All right, so 29, I want to set it equal to 0, step 1. If you notice, my highest power is already positive, so we want to keep him here. We want to move everything else to the left side in this case because x squared has a positive number. So that means I got to move this guy. He's positive 3x. To move him across the equal sign, we make him negative 3x. And what you do to one side, do to the other. He turns into 0 or cancels out. And now we rewrite. We have 3x squared. We actually could combine these because we have an x and an x. Those are like terms. So negative 12, negative 3, they're on the same team. So it's going to get a bigger team of negatives. So negative 15, and we keep the same. X all equal to 0. This is in standard form, so I have to find my GCF. So my GCF, let's do it over here. So I'm going to make a list of the smaller number between the two terms. So 3 is the smaller number. What divides 3? Well, 1 and 3. So now I have to check using the bigger number in my list. Can 3 divide 15? And the answer is yes. It divides it evenly. So 3 is my GCF. Do they have a common variable? Yep, they have both an x. We picked the lower powered x to put in my GCF, so it's x. And now we divide by our GCF. 3x, 3x. And now we're going to put this in factored form. So 3 divided by 3 is 1. X squared divided by x, you're left with 1x. Negative 15 divided by 3, that's negative 5. We have 1x on top. We're taking 1x away, so no more x's in that guy. And then to turn into multiplication, we use our GCF of 3x and multiplying from. So this is still equal to 0. Step 3 says put each factor equal to 0. So let's do that over here on the right. So 3x is equal to 0. And x minus 5 is equal to 0. and we're going to solve each equation. So here we want to divide by 3 to get x by itself. X equals 0. Over here we want to add 5 to get x by itself. X equals 5. Okay. All right, guys, I'm going to get you the checkout code. Please use the rest of the period to finish up this assignment. Take a chance to look back at weeks 7 and 8 in your notes or on your assignment for the test. Okay? So please check that out, and I'll get you the checkout code. And once you have the checking code, you are dismissed.